Yes, sir, we are starting.
A good signal. That's more important because you are located in your village right away. Okay. So just make sure your network is clear. It will be good enough. Thank you.
Okay. Thank you. Sir, next, good afternoon.
Very good afternoon, sir. This is.
And welcome.
Thanks, sir. Thanks a lot. Thank you.
And thank you for joining.
Thanks, sir. I just thought like he just told me around 1 o'clock. I was coming for the lunch. Then I thought, let me just good enough, sir. So you just let me know. So by the time once it is done, then I'll take over. Thank you.
Yeah. So I'm starting from my end. Yeah. Good afternoon, Mr. Ramesh, Mr. Pradeep from Apply Volt Hyderabad, our today's session experts. Good afternoon, participants, and welcome back. We are in day 4, session 3. Our earlier session was a bit delayed, so our session 3 was about to start at 2 p.m. but we took 15 minutes more as our earlier session was finished 15-20 minutes. It was finished delayed 15-20 minutes. So maybe a kind of compensation for that. We will be beginning session 3 of day 4 with expertise from Apply Volt company, which is located at Hyderabad. This session will be on hands-on session, or this session will be on hands-on session on image and video processing platform on FPGA. I am having very pleasure in welcoming Mr. Ramesh, who is co-founder of Apply Volt, and Mr. Pradeep, his colleague and senior application engineer with Apply Volt Limited, Hyderabad. We welcome you, sir, and I hope all the participants will go through this session and will have a hands-on, will cite an hands-on image and video processing on FPGA platform. As far as Mr. Pradeep is concerned, Pradeep is a senior application engineer, as I have told. He is working with as a senior application engineer. His qualification is like he is asset design and verification from NIEL IT Calicut, MTech in VLSI design from JNE UK AP, and BTech from ECE, BTech in ECE from CSIT Kakinada. He has worked as an intern for ASIC design and verification using System Verilog at Sion Semiconductor Private Limited, Hyderabad, and as application engineer in Tenet, Hyderabad for 2 years. He has provided training and conducted workshop on hands-on on image and video processing with FPGA platform at JNTU Kakinada, SRKIT Vijayawada, QIS Ongele, PVP, SPE Vijayawada, and number of institutes. I welcome Mr. Ramesh, sir, co-founder of Apply Volt, and Mr. Pradeep, senior application engineer with Apply Volt Hyderabad. We request you, sir, to begin your session. I am requesting host of this session to make you a presenter. On behalf of all of us participants, on behalf of my institute, we once again welcome you. We are thankful to you for readily accepting our invitation for this Atal AICT sponsored 1-week online mode FDP on recent trends and applications in biomedical signal and image processing. Just to inform you, we have got around 200 participants for this 1-week FDP from across India, from almost 16-17 states. We have got representations of participation. These participants are from various institutes, engineering and technology institutes, polytechnics, and etc. I hope and I am confident that your session will be useful to them as far as signal and image processing and video processing is concerned, and its FPGA implementation is concerned. I will hand it over to you, Mr. Ramesh and Mr. Pradeep. We are making you a presenter. You can kindly go ahead with your presentation and session.
Thanks, Dr. Milian sir. It's quite good to see there are so many people who have attended this program today. In fact, I'll just share my screen once, then I'll just start with, and I'll be taking about 5 to 6 minutes of your time. And once that is, without wasting much of the time, we'll move into the technical part. I'll just share my screen, sir. I think my screen is clear enough to everyone. Someone can put it in the chat box or just unmute yourself. Mr. Deshmukh sir, if you're available online.
Yes, sir. Yes, sir. It is.
Thanks, sir. Thanks. So, in fact, this was a very good thing. Thank you, Ruchira. Like I have been seeing here, like it has been audible. This is Ramesh Naidu here. Just Dr. Milan sir has introduced us, and in fact, we are very happy to be a part of this program. And as I started my career with Texas Instruments way back in 2004 from Bangalore, then I worked there for a couple of years. Then from that, I have shifted to Xilinx and Metagraphics. This is the domain which I've been working for a longer time. I have worked in a couple of companies. So if you go into my LinkedIn profile, you can see from the technical, I have moved more into the commercial, some techno-commercial activities as of today. I've been there in the market specific to the education sector from 2004 onwards, as I told you, and catering to all India IITs and IITs. That is one vertical which I particularly look after when I used to be an employee. Then after that, when I started Apply Volt along with one of the friend in Synopsys in US. So we both are the partners for this, and our main focus is into two domains. One is the defense vertical, and other is the academics vertical. I am very much serious about the academic verticals and some part of defense. In fact, HAL Nashik also I only look after. And similarly, my other colleague, he takes care about all the defense organizations across India. And as you know here, like we have Pradeep is there. Pradeep was good enough to spend some time today because he has visited our college a couple of months back for some of the demo. And he told that, sir, I will be taking this particular college, any sessions is there. So I just told him whatever program it comes across from any engineering college, please address them, irrespective the financial factors, sometimes based on the situation and the requirement. And as I apply Volt, I told you two verticals, defense and education. Okay. And I welcome everyone here, like the number of participants I've been seeing every 2 minutes, there are a couple of people are increasing. And welcome you all once again, and thanks the management department of EC, Dr. Milian sir and Deshmukh sir. I didn't meet you people directly, but probably next after pro-COVID or post-COVID, I think I'll be meeting most of the people shortly. So welcome you all, and my sincere request everyone to be on mute, switch off to your video because the network will be good enough. If there is any issues, you have every right to ping in between, interrupt in between, and trouble my colleague and my friend Mr. Pradeep as much as possible, so that he'll spend more time. And only the request that next time whenever we are doing any program, with irrespective of any of your colleges, we would like to have little more time rather than 1.5 hours, because it is very short and we won't find much time to concentrate on a specific topic. So probably we can plan it in a bigger way in the coming days. So thank you for the opportunity. And as I told you, I am one of the co-founders for Apply Volt. It was initially registered at Vijayawada. Now we are present at Hyderabad and Coimbatore. Coimbatore, we manufacture all our PCB machines and PCB design machines and IoT parts. We work there. In Hyderabad, we concentrate all the academic sector in South and East India, some part of West like Maharashtra and Gujarat, but not directly. We do have some traders there who are working with us, but we are willing to work directly with your colleges, provided the opportunity is there. And Bangalore team specifically concentrate on the signal processing and ASIC designing, where we address to the corporate industries. And as to be a key point, my employees, and in fact rather I call it my employees, though I have written it our employees, because my employees I am very much confident with them. Without them we are not here to present all these sessions. And obviously the customers who are always engaged with us from the day one. And the different technologies where we are associated. Xilinx is the career where I started. Now we are working with AI and ML solutions from NVIDIA, Digilent, as you are aware, Metagraphics for the ASIC designing and cable harness, and electrical power systems also we are working with Mentor graphics tools. Most of the people are aware Mentor is very specific to ASIC designing. No, they are present in the multiple domains. Cable harness, wiring harness, electrical harness, that is a different area where we are concentrating. And the most important tool which we focus from Mentor is the Questa, which is for the verification part. And LoRa is the new technologies, and the latest one where people are working line of sight should be about 4 kilometers, 5 kilometers, rather using all this Wi-Fi, Zigbee and Bluetooth. So LoRa can address to the number of applications, which I will take you in the next slide. And right side you can see the PCB prototyping machine, which we work and we supply in the colleges, as well as we use it for the small scale industries. Speed goat is again nothing but for the electrical domain, for the real-time hardware simulation. And ANSYS, most of you are aware, HFSS and all that. And mechanical again we concentrate in the ANSYS part. And here I am presenting only the solutions which we give it to the academics, not specific to the industry. Industry I am not presenting here because this whole sessions are addressed towards the technical universities and the technical teams. So VLSI industry is our main area which we focus on as we are talking today. And recently we have come up with NI, AI and ML labs, IoT labs and embedded labs using Raspberry, and all these are outdated. We are focusing more on the LoRa solutions, which we develop, we give a solution. And low-cost PCB prototyping and antenna machine fabrication units, which are used in specifically if you see any universities or the autonomous colleges. Second year of electronics students are getting exposure to this. Earlier days, we used to import from China or from Japan or from US, which was costing huge. Now we are manufacturing in India. Under Make in India concept, we are using all these solutions so that an electronics engineer can know from the design part till the product. So if any college is having this small setup, they can have a feel, come up with your idea and launch a product. That is the concept what we are working on. DSP again from Texas Instruments, RF solutions from we have ANSYS and Siemens, robotic solutions again we have, and ANSYS 3D printing solutions. And last but not the least, we are always open to give some time to the student community, that is Polytechnic, BTech, MTech, research scholars, and specific to the junior faculties and the faculties who are working in our domain. And we are always open to the number of colleges who are working in the different areas. Some people are working in some specific domain and they want some support for the PhD. We do that technically based on the time and the time constraint. Okay, it's not like that we won't do it. We will do it, but it's not a complete handhold. But the support part, tool related or the hardware related, we can provide. Okay, and we are working with the internships and all that, which is going on. In fact, this COVID has given us an opportunity to train about 1,600 students as of today, including yesterday's number. It was 82. 1,682 is the number where we have completed certification programs, online and offline trainings. And I am very happy to talk about this one of the FPG kits, which is our design, our own product. There are so many products coming up in the market from Design, from Xilinx, from Altera, from Intel. This is one of the design where we thought it will be fit into the education sector specifically, because you must have seen Artix board, Jet boards and all that. So, but Artix board, this particular board will support original version of Xilinx and the older version of ISC, both the flow, like complete Vivaro flow, where you can do the partial reconfiguration, high-level synthesis, or if you are doing any prototyping. The advantage of this board is that below 20,000 of the cost, we are able to come up with a inbuilt Wi-Fi, inbuilt Bluetooth, inbuilt 0.3 megapixel camera, and the TFT screen for the video and image application. But what you can see here, this all can be dismantled also if required. But we are giving it as a bundle to any engineering colleges across the country. And this we have launched 1.5 years back, and we are quite successful in selling about 800 plus numbers after so many people saw the development work and the warranty of it. Most of the OEMs gives 90 days, but in this board we focus 1 year warranty without any issue. Irrespective a small issue, technically we replace the board with a new board, irrespective having a servicing for that. And major advantage in this, when we compare with the Digilent and Xilinx board also, warranty is major issue, and other is the peripherals. And third part is DAC and ADC both are present in this board. And in this board we are having 3 flavors. One is Spartan, other is the Artix, and third one is the Zinc. And now we are going to work on the Syntex series also, which is going on. Probably after 2 months we may launch it shortly. And these are very cost effective when we compare with any OEMs. This we have launched under the Make in India concept in Hyderabad. And LoRa is one thing which I was just about to tell you. This is one of the products which we have designed in the month of June using Raspberry and FPGA and the LoRa solutions. This we have implemented in our office as well as we have implemented in most of the temples, malls and airports. So initially people were not ready to go for it, but as we told, like, okay, maintaining the distance alarm you get, and you get who are not wearing the mask. So everything is noted. Now recently we have uploaded the thermal part also. With certain 6 feet of distance, it will tell you what is his temperature. So I won't say it's 100% accuracy as of today, but 90 to 95% accuracy data is coming. And already we have implemented in the couple of municipal corporations in different cities like Vijayawada, Vizag also, and in some hospitals. This completely we have used the LoRa technology here. And this is one more thing, LoRa-based animal tracking system, which we have done 1.5 years back. That is in Madhya Pradesh, one of the forests, where near the fencing there are so many animals come in, and sometimes they just to make sure the electric circuit is given in the fencing part. To avoid that, we have given this animal monitoring using LoRa technology there. So we have put it in a trial basis. So expecting something good should happen. So it was our effort for last 1.5 years, which we've been showing to the people. And right side is again the project called as Cultivate in the government of Andhra Pradesh, where they are working with all the rural parts. So Cultivate is one of the company who has given us a sub-lease or the sub-project work to develop this solution, where apart from your regular moisturing and all that, the leaf quality also it can sense at different locations. And not to take much of the time, similarly, we've been working in multiple domains, and this is the few customers where we are associated, we have signed MOUs. So some colleges like SRM, Amravati, and with KLU, these are the couple of private universities where we have signed MOU. Scaling them from second year till fourth year, we have the one-part solution for them in VLSI domain or in IoT domain or in PSA. But most of the colleges are associated with us in the area of VLSI. So that is our main focused area, which we've been doing. And we are present in NIT Delhi or couple of NITs in Raipur, Durg, and IIT Kharagpur and all these areas also we are present in terms of supplying the products. And MOUs we have in the private universities, not with any government universities as of today. And I particularly work with JNTU Hyderabad and JNTU Kakinada as a Board of Studies member for the Electronics and Communication Department. And this is our different things. In-house, we do some trainings. We go to the college and we do. Sometimes we invite students to our place and do. And if pre-COVID, every year about 40 to 50 members, intern students come to us. They work with us and they used to go back. But now this year we have started paid program also because of this pandemic. And probably post-COVID, we will be resuming all these activities across the place. And these were the few feedback forms recently which we have received. And every month, first week of month, we launch an intensive program, and we cut off the number of students of specifically to third year, somewhere around 50 members. After that 50 members get over, then again every month we start in the first week. So we work on physical design, we work on verification, we work on the front-end solutions, and recently from October 3rd, I think, we are launching a program on the advanced VLSI verification and design tool using Xilinx. It's about 20 days of program. It's an internship and training program. So it's a completely online evening session from 7 to 8:30. So we have not done a proper marketing across India. We are mostly focusing Bangalore and Hyderabad. And in fact, every batch, this is the 7th batch we are going to launch on October 3rd, already filled with 50 people. And if there is a college like us who want a specific or a tailor-made or a custom-made training for your students, we are ready to do that. Irrespective of the college, irrespective of the number of students from the third year or fourth year. And some MOUs we do from second year till fourth year, we take them a complete cycle of from PCB design till the product launch. So this kind of activities we are doing. And my contact number is also there, very WhatsApp number. So you can have it with you. And not to take much time now, I just would like to give Pradeep to take over from here. I'll stop sharing my screen. And my sincere request, Pradeep, is a very soft timing, sir. And next time, whenever we are going to involve, if time permits and everything goes well, definitely I'll be visiting your college, and sometimes we'll try to do something good at your center. Dr. Milind sir, thanks a lot for the opportunity, and Mr. Deshmukh sir and the Department of ECE and the dear participants who have been here. So let's not waste much of the time. Okay. And any queries, any faculties, please put it to my WhatsApp number 9009000485. I think Pradeep will share my number, and that is my WhatsApp number, which I will, in fact, I reply via that. Okay.
Thank you, sir.
So thank you guys. Thanks a lot. Thank you, sir.
Thank you so much, sir. Pradeep sir, I have shared with made you presenter.
Thank you, Ramesh sir.
Thank you, sir. Thanks a lot, sir. Thank you.
Thank you very much. Thank you very much.
Pradeep?
Okay, sir. Okay, sir. Can you share your PPT? Pradeep sir? Am I audible? Yes, sir. You are audible, sir. Yeah. Can you make me as a presenter, sir? You are a presenter, sir. No, it is sir. Yeah. Pradeep sir, are you able to share your screen? Hello?
Hello, Pradeep sir.
Deshmukh sir, it's audible. Your voice is audible. I will try to reach him over phone. Just a minute. I don't know, like, there is one.
उधर देखो ना यार, मेरे पास नहीं है।
देशमुख सर
हाँ?
तुमचा माईक बंद करा. हाँ, सैटरडे को है मेरा क्लास. सैटरडे को डाल दो भाई, इधर डाल दो.
Deshmukh sir, can you make Pradeep as a presenter? He is not able to see that.
Hello?
Sir, I think Pradeep sir left the meeting.
He is joining back. Kindly make him a presenter. He is joining back.
Yes, sir.
Yes. Video processing applications, and we want to set any one type of problem statement, that what type of analysis we want to do in the image processing or video processing. And
So coming to that, trends or technologies, we are looking into that. So right now, the idea of technology files, okay, manufacturing ICs in terms of nanometers, in terms of micrometers, like you are concentrating on the MOSFETs, okay, semiconductor MOSFETs. So in this, we are also coming to concentrating in our recent technologies for available in our markets. Like you can see the recent mobile phones or recent televisions. There are everything is in smartphone conditions and smart TVs. Those are developed by or manufactured by technologies which related to the nanometer technology files. Okay, in that we are using a FinFET technology files. In that we are using a master technology files. So coming to that FinFET technology files, what will happen according to the Moore's law? Every 18 months, we are concentrating on the increasing of the device in terms of area point of view. We are concentrating, we can take it 2 into 2. For example, if you are taking a dimension of a die, which is having a dimension of 2 and 2 nanometer, like you can identify that in terms of nanometers. Here, the die size consisting of 2 into 2, it is a square base. In that, you can fit some certain designs, like your full adders or full subtractors, or you can include microcontrollers or microprocessors. Okay, include microcontrollers and microprocessors. If you are, after 18 months, what will happen? The die size must be same, but you can fit this into 2 parts, one microcontroller and another microcontroller. We are having 2 microcontrollers by using another 18 months or 2 years. It is defined by using Moore's law. So reason behind that is the technology file. That's why we are concentrating in present trends in 7 nanometer files. 7 nanometer technology files. Okay. So coming to that, by using these 7 nanometer technology files are very low-end technology files, what are the different changes in our FPGAs has been happened from past 10 years we were concentrating. So past 10 years we can concentrate the architecture of FPGA boards or FPGAs available in the market. So these are the different technology files. Based on these boards, we are want to perform our designs by using like image processing applications, using a DSP flights. If you want to design your own network issues like I2C, UART, or PCI Express application to send the information from one source to another destination, we can using these types of boards. Even though the link board architectures or vertex 7 architectures are used in ISOs and DRDOs and DRDOs for the transmitting of information from space to our station. Okay. So based on this, we are always concentrating on today's topic is in Zinc architecture, that is an SOC. So what are the internal architecture it looks like and what are the thing is there, we want to proceed in our coming slides. So if you want to observe that the logical cells or logic resources are available in terms of K to 20K to up to how many? 2000K. See, in vertex 7 we are having 2000K resources are available. That means those number of logic resources we can use to develop our own designs in a FPGAs. Okay. So coming to that, you can also identify the trends or nanometers has been changed. According to that, you can also identify the voltage rating is also changed. For our individual laboratory, we are going for any IC lab, LICA lab or RICA lab. In our laboratories, we are using an IC name called 741 or 75 timer. It is having an 8-pin IC or it is a 4-pin IC. If you are applying that particular IC, your voltage ratings or you are applying the voltage level is 5 volts. A minimum of or maximum of 5 volts to conduct the IC. But if you are seeing our FPGA ICs, it starts with a maximum voltage of 3.3 and the minimum voltage of 1.8. So this much of drastic change has been happened in our technologies. Okay, in our technology. Then coming to that, what is internal architectures? How it looks in FPGAs? The internal architectures has been constructed by using a CL-based combinational logic blocks. Here inside the CL-based we are having a slices. This is our slice module. Inside the slice modules we are having LUTs, multiplexers and carrier chains as well as a flip-flops are existing. So these types of LUTs are called 6-input LUTs, which is constructed by using one from Mach standard to 5-input LUTs. It is used to design to enhance our designs by using how much of area it is occupied. For example, you are designing one processor and you want to identify how much of area it is occupying. So it is identified by using these slices and LUTs, this much of slices and this much of LUTs. For example, you can count in terms of LUTs. So you can see some LUT conditions here. These are the logic resources. Out of 20,000, 20K means 100, 20K, 2,000, you can consider 2,000. Out of 2,000 resources, you can use in your designs around, around 50 or around 2 also. Then according to that, my area of constraint is this much in terms of percentage, like 0.5% or 10%. You can count and you can view this much of area it will occupy based on the slices and based on the LUTs as well as based on the flip-flops. You can calculate for the fundamental uses. Coming to that DSP slices. So why DSP slices are very important in the FPGAs means while we are performing some image processing applications or signal processing applications, noise applications, or if you are performing in video processing applications, for that we want to have certain registers to store our data and to retrieve the data by using this DSP application. So we are having a dual port DRAM register and AB registers also there, and we are having another type of multiplexer. It is for 25 into 18, and we are having some adder multiplexer. ALU is also available, and we are having that mux counters and registers and carriers also there. Using these fundamental bits, and we want to support our design in terms of DSP slices. So the combinational logic blocks is also consisting of the slice type of DSP slice as well as a logic slice, we can call it as. So these are the technologies, and inside the FPGA is what we are focusing on. So we are always focusing on today's board is this board. So it is one of the best board available in the market. So it is good for the applications like SOC type of application, system on chip, because this board is consisting of both logical resources and system resources. That means PS and PL, programmable system as well as programmable logic. So one of the programmable systems has been constructed or designed by using ARM Cortex A9, and it is a dual core processor. It is a dual core processor, and the PL system has been constructed by using an architecture of again Artex 7 and Kintex 7. What we see in the previous slide, Artex 7 and Kintex 7. So these PS and PL has been making a communication channel by using an AMBA architecture, that is an AXI4, which is used for the prototyping application. It is used for the prototyping application for the communication between both PS and PL. Both PS and PL. Okay. So what is the coming to here? We are starting where to start and where to end. So I'm giving some individual steps or design flow. You can call it as design flow. You can see what is what and where to end and where to start. Okay, so initially we want to identify what is our problem statement. That means what we want to design, what type of application we want to design. We want to make such an idea. So for example, edge detection, or for example, you can go for pixel clarity, or you can go for what do you call it, enhancement of the image. Like that, you want to identify what is your problem status. Later on, we are coming to define our verification by using different architectures. Later on, we are going to applications by defining different architectures. Like what are the verification domains initially we want to do. Architectures are initially we want to do for .am codes, like MATLAB codes. We want to identify, you want to write your own MATLAB code for your different architectures or problem statement, and you want to verify that is that enhancement or is that design is properly working or not. And you also verifying by using another type of modules like Simlink modules. You can call it because you want to easily drag and drop your Simlink block set and easily enhance your design. If it is this type of analysis is very important. Start our designs. So let that. I want to also fill parameter analysis. That means design it is selected. Like edge detection parameters or blur image parameters, noise are existing in your base, then you want to re-verify or redesign or reconstruct our own designs. So after that, if you are satisfying with the design verification in your .m code or your Simlink block set, then you can reclaim the design with a system generator. So here the system generator is related to the Xilinx. What is the target we are saying? The target is our FPGA. So for constructing or for designing our own FPGA concepts in our designs, so you are going for the system generator. The system generator is nothing but Xilinx system generator. What type of Simlink block you have designed in the previous MATLAB, the same Simlink block has been reconstructed in your system generator block set using Xilinx block set. Okay. So let's you want to map that just like your Vivado toolset. So why you are going to map that with respect to Vivado toolset is you are mapping the Vivado or the entire system generator block with respect to certain hardware. It may be a Kintex hardware, it may be a Vertex hardware, it may be a Artex, or it may be a Zinc architecture hardware. So you want to map to that particular hardware to identify what is the area it is taking, how much of area it is having, and what is the power analysis. You want to identify the power factor. You want to identify the delay, how much the data has been transmitted from delay parameters. These things you want to identify. That's why we are mapping the system generator to the Vivado, Xilinx Vivado toolset. Later on, you are generating your hardware compiler to RTL. That means it is giving the entire RTL code, register transfer level code, in terms of either you can go for a VHDL code or Verilog code. In terms of you are going for a VHDL code or Verilog code, then it is very useful to work out in your Vivado toolset. Later on, you are going for the, sometimes it is also giving that IP. It means intellectual property code. Intellectual property code. You want to make your own IPs to use different modules, your designs, then you can go for an IP core also. So then you want to implement in a FPGA. So coming to the problem statements, if you are taking an image enhancement mode, we are having the color image, we are having a gray image. These are some examples of the image. So this is the problem I am taking we can take so many problems like grayscale image, enhancement image. Okay. So coming to the hardware implementation part, here I'm showing you on block diagram. The block diagram consisting of how to insert an image and how to retrieve the image by using a system generator, and where exactly our hardware is using and where exactly our design has been evaluated. So for the design perspective, we want to concentrating on both image insertion and image retrieval. So in this, we are having only three major blocks. One is image pre-processing block and image processing algorithm. What type of algorithms we want to do? Like algorithms like image enhancement algorithm, grayscale algorithms. These are the algorithms we want to apply here by using a Xilinx system generator. Okay, we are applying the algorithms by using Xilinx system generator. Later on, after getting those outputs, in terms of we are taking in terms of post processing process. Okay, then we are viewing our image. So coming to the Xilinx design flow, after retrieving your image, you are satisfying with that image enhancement in the previous slide. Then after that, your conversion. That means you want to go for the hardware implementation part. In that, you want to identify the area, power, delay calculations. So for that case, the Vivado design flow is suitable for you. So here, the design entry means it is nothing but your hardware RTL code. So RTL code is also generated by the system generator. Later on, you want to verify the synthesis part. That means you want to map how much of area it will take in terms of LUT form and in terms of CLV form, in terms of flip-flops or in terms of DSP slices, in terms of block ranks. Okay, these things have been given the results or the synthesis part. So the synthesis is always concentrating on what is the area of your design. This is always concentrating on what is the area of your design. After that, if you are satisfied with your design constraints and everything, then you are moving to the implementation part. Or otherwise, you want to go back and redesign your design implementation. So design implementation to optimize in terms of CLVs, the previous, this is very older things, but right now we are only concentrating on FPGAs in the present trend. So in FPGA, what we are going to do, we are going to do in mapping part. That mapping part means where to exactly map the each and individual LUT, CLV or DSP slices. That is a mapping part. After the mapping has been done in the internal IC, then you are going to place and route everything. Place and route everything. Then you want to generate a mixture and debug into the FPGA. So this is a part of my design flow of Xilinx. So we are concentrating on these steps for coming lab. So yeah. So these are the numbers. You can note down it, please, and you can mail us for any further information. Please note down it. I will start the hands-on session right now. 900-900-485 and knr@applyworld as well as applyworld2017@gmail.com. So, right. So to start with your design, I want to go for the Xilinx. So in my already I installed the Xilinx Vivado toolset as well as I installed MATLAB. So both the versions must be in a same year or a version, compatible version. So I'm using here 2019, the latest version of Vivado. So Xilinx toolset. Here 2019 system generator is available. So going to the system generator 2019, open. So here it is opened. So I'm running as a administrator. Fine, very good. The tool is opening. When you are clicking on the system generator is existed in Xilinx block set. The system generator is existed in Xilinx block set, but it is used to open in terms of MATLAB. It will open in terms of MATLAB. Because I want to use Xilinx block set in Simulink block sets. Yes, it is opening right now. Yes. So this is your MATLAB, and I want to go for a certain folder actually. So I'm going to certain folder, like you can choose any folder what you want. So I'm taking one path and I'm copying that same path. So what you want to do, you want to copy the path, or you can browse that path. Particular path doing in my C directory, I'm doing in D directory. Okay? In the directory, I am opening my Simulink. So click on start Simulink block icon. This is a start Simulink block icon. You can click on here. So after clicking on, you can open your own Simulink block set. Simulink tool is used for you can drag and drop your own design, and you can give some information to that to identify your own design. You can construct signal processing, like you can go for IAR filter, FIR filters, okay, signal noise ratio form. You can use this tool set. So this is your Simulink block set tool. So here I am taking a very new block. So new block, a module. If I am creating a module, I am waiting a second because still Simulink block set is starting. Give a time for this one. You can see the cautions. If it is ready, and we can start. I click on blank module for creating a module. So I'm taking a very new empty module here. It's creating. Yes, it is created. Now we want to give any name. You can give it. I'm giving as a design name or anything else. You can click on save button. Or clicking on save button. Automatically, when you click the save button, it will be stored in what you have given path is there. The same path. So, yes, already I'm having something like design 1 and design 2. So, I'm taking as a design 3 like that. Okay. So, let me take it as a design 3. So it is a design 3. Now I want to go in for the library. So library, click on here, library browser icon is available. While you are clicking library browser icon, you can view so many libraries that are existing. But basically what we want to require in our according to our slide, we want to design pre-processing block and algorithm block and post-processing block. These 3 blocks are the very important blocks to design. So based on these 3 blocks, we want to implement step by step. Okay. So coming to that, if you want to go for the pre-processing block, so what you want to do, you want to use the image. Okay. The image is there. So for that, you are going for the computer version toolbar. Okay, this is a computer version toolbar. In that toolbar, you want to give in some source. So you are giving a source. Giving a source means you are giving an image. So here, in the source window, you want to go for the image form file. Okay, this is the image form file. You want to take this toolbox. Just toolbox. So you want to take the toolbox here, drag and drop. Okay. Now the image box has happened. Later on, what I want to require, followed by, actually the image is in terms of rows and columns, like 128 into 128 or something like 750 into 750. These are the image in terms of RGB, color image, in terms of RGB color image. For the resizing purpose, you want to go for the resizing purpose, you want to go for the something like, why I'm going to the resize? The resize is very important. Reason behind that, I'm giving certain image in a bigger manner. General image I'm giving. I want to convert that image in terms of in different form. So, for example, in the same window toolbox, computer version toolbox, go to the geometric transformations. So in the geometric transformations, you are existing as a resize. So you can take the resize. After resize, you want to go through the conversion. Because actually the image in terms of 2D. For the conversions, I want to go for the conversion. Conversions. It is existed in the same toolbox. You can go for the DSP toolbox. In the DSP toolbox, there is a signal management. In the signal management, you can have signal attributes. In that, we are having 2 types of blocks are there. One is 1D to 2D and 2D to 1D. So I require these 2 blocks. One is for the 2D to 1D, another is for the 1D to 2D. It is in the post-processing block, it is in the pre-processing block. So I want to take here processing block, and I also take right now I am taking that post-processing block also. Okay. After that, in the same attribute, we are having a frame. I want to transmit my image in terms of frame by frame. I want to transmit my image in terms of frame by frame. So for that, I'm using another toolbox is called to frame conversions. in frame conversion. Okay. Later on, I want to use buffers. Okay. Unbuffer and buffer. Okay. These are the buffers to hold the entire sample of data. For example, if I am giving a resize type of 128, so entire 128 coming directly into the frame. The frame is directly sending to the input means it cannot, input cannot capture the entire data. So it will hold certain registry type. So I am using a buffer. So I require another type of buffer to unbuffer, that is only buffer. It is in the pre-processing block. Later on, I want to give, this is my, you can call it as, you can make a simple connection directly. This is my post-processing block. Sorry, pre-processing block. This is my pre-processing block. Later on, what is the next step? It is that processing block is completed. You want to make certain algorithm. So what I want to do here, I want to do the algorithm in terms of prediction. I want to add a certain constant value to my image. I want to add a certain constant value to my image. So for that, I am going to the library. I am using what is the actual algorithm design. The algorithm has been designed by using Xilinx system generator. Xilinx system generator. So I am going to the Xilinx toolbox block set. This is my Xilinx block set. When you configure the Xilinx reverter to MATLAB only, this block is available. Otherwise, this block is not available. Okay. In that, going to the basic block set, I want to take my input as well as my output. These are the two things I want to drag and drop. So this is my input signal and this is my output signal. So in between input and output, what I want to perform? I want to perform adder. I want to perform adder. So for the adder block, where is the adder? Actually, adder is in terms of math. In math library, we are having adder subtractor. Add subtractor. This is my adder. So I am taking the adder subtractor block from the math library, and I am giving the connections. So later on, I want to take the parameter also. I want to take the constant also. So this is my constant. The same math library. Some connection here. So that giving of everything, I was completed with my second block set, that is system generator. I want to performing an algorithm in terms of adding some noise or some signal to my design. Okay? To my design. And later, I want to perform a post-processing block. So, for the post-processing block, so I'm having already there is one unbuffer. So, what is the data I'm having? The same data I want to unbuffer it. And I want to retrieve the values from one form to 1D to 2D because I want to view the same image in terms of 2D form. So I want to retrieve it. And I want to view my output. I want to view my output. So the output is also existing. Going for that, going for that computer version toolbox. In that there is a sync is there. In the toolbox we are having a video viewer. So take this toolbox and you can give it in the output side. You can give it in the output side.
Hello.
Hello? Sir?
Okay.
Right. So this parameter devices and everything we can connect. But in between, we also connect to that data type conversions. So because what is coming, to you what type of data is coming in terms of binary form or in terms of radix form, like that. So for the by confirmation, you can go to that. So the signal attributes here, in the Simlink there is a signal attributes toolbox is there. In that toolbox you are having data type conversion. So you can take that data type conversion also. It is attached in between the output port and as well as the buffer. Okay. So I want to add this block also. Right. So this is my actual block. Meanwhile, I want to add my system generator also. So the system generator is existing in where? Actually, it is existing in the Xilinx block set. So in the basic block set, there is a name called system generator icon is there. This is the thing. All the operation has been done by using this block. Okay, system generator block. This is the compiler block, you can call it as, or specification block, call it as. So, okay, very good, fine. So I want to view what are the individual parameters I want to insert right now. So I want to insert some image here. For that image, I want to make some resizing here. After that, I want to converting from 2D to 1D. After that, I am giving in terms of frame by frame. Frame by frame. Later on, the unbuffer is also going to the input side, and I want to add some addition or subtraction. Later on, I want to replace the data. So, what I want to do? I want to take another image file, Control C and Control V. Yes. This Control C and Control V. What is the input and given? I want to view. So for that input purpose, I am viewing the viewer here, video viewer here. So WCA can open and change the parameters for the design. Okay, WCA. So when you clicking on the image form file, the form file is mainly consisting of file name and what type of data it is. And actually, if you change the image signal in terms of separate colors like RGB, you can use the R to one type of signal, G to one type of signal, and RGB to another type of signal also. But I am taking right now, it is in a one-dimensional signal. That means entire data I was taking, and I am browsing my file. That means I am giving my image file here. So I am having one image here. I am taking the same image. So then I am applying this one. Later on, I want to change my data type. Because data conversion is there, I want to choose what type of data conversion. I am using the unit 8 data type. That is like unit 8 data type I am using here. And now, after completion of this block, I want to go into the resize block. So here, the resize block is consisting of so many specifications. You can identify the specifications like the number of rows and columns. What do you want to display? What type of image wants to comes into the screen. So I am taking the rows and columns, the image. So here I am changing my 128 into 128. Rows means 128, column size is 128. Like that I am changing here 128 and 128, and you can apply. So these are the same things because you are changing the vectors in terms of 2D to 1D form vector form, and the frame size is also okay, frame by frame. But coming to the buffer, how much of data you are taking? So what is the size I given resize? The column size is 120. So you are taking the column in terms of two columns, rows and columns. It is 128 into 128. But coming to the unbuffer, I am only having to insert my data or insert my information of pixels in terms of 128 form only, because the frame I am giving, that is 128. Insert it 128 and click apply. Okay. Then I want to change my input gateway in. What is the gateway in I want to conversion? Yes, I am using for fixed point in terms of unsigned integer, and it is in terms of 8. So for 8, that means 8 bits, you can consider it as an 8 bit and click OK and OK. Apply and OK. Okay. If you want to, I want to add some constant what I mentioned previously. The constant is maybe right now I'm taking a 50. Later I can change any value according to the 50 or some factor. You can easily identify, and also it is a fixed point, not a floating point, and it is a type of 8. I'm taking a 8 unit. Okay and okay. And I'm adding here and add only adder. If you want to take the subtractor or add a subtractor also, no issues. And I'm not using any delay here. Latency means here the delay. Z power 1 minus 1. That is a latency. It is having 1 unit of delay. So I'm taking as a 0. I'm not applying any delay right now. Right. And the output is, I'm not changing any output right now. It is only the same thing. And click and OK. Now, what about the conversion? Data type of conversions. What is it? So, if you are going for the data type conversions, you can see that in the property window, you want to identify the output data type is what type of data it is coming, or you can taking, you can identify. So, the data type is in terms of unit 8, and it is a real world values, and you can take it as a round. Okay, and click apply and OK. So coming to the buffer, unbuffer, this is a buffer. But coming to the buffer, you want to mention the output size is what. So I mentioned already that the input size, the size of the resizing, I am taking as rows and columns in terms of 128 and 128. So the size is 128 into 128. The size is 128 into 128. That much of size of image I want to see in the my output side with a certain constant value normalized, adding of constant value normalized. So after that, here from 1D to 2D, it is asking how many rows and how many columns. Again it is 128. Again, it is 128. 138 rows and 128 columns. 128 rows and 128 columns. And click OK. So I want to view my output in terms of 128 into 128 form. Then I want to save the design, because all the changes have been done. Still not I am using my system generator right now. Okay. But I am clicking on run to verify the output is coming or not for a while. That is going on. Processing simulation started. Yeah. Everything is all in input and output. Yes. Yeah, very good. So actually this color image, you can observe that this color image what you call as actual RGB size. What is the size here? It is a 531 into 430. This is the size of my image, and what I am retrieving in the output side, you can see the retrieving of output image. What is the resize? You can observe that 128 into 128. Okay. So here you can see the size here 128 into 128. So sizes have been taken. Okay, the same size has been existed in here. If you want to change some different, for example, I want to invert my image. Yes, you can invert your image. So I'm giving some small examples very quickly here. Later on, I'm going to the FPGA implementation. So some question is happened here. What is the chat box is here? Yes. Respect to that 128 into 128 random value chosen, sir. Sir, I'm not choosing. You can take the random value. Yes, you can take the random value also, sir. From Sai Divya. Yeah, ma'am. Sai Divya, ma'am. You can take the random value. You can take 64 into 64, or you can take anything according to your size. First of all, you want to know what is the actual image size. My image size is my input image size is 531 into 430. So that's why I am taking like this. Okay. You can take like that. How can I run in the MATLAB script into FPGA? Sir, I'm coming to that example, sir. I'm showing that. Give me time of 1 or 2 minutes. Right. So if you want to see some other applications, for example, you can take that inverter in place of adder. You can take the inverter directly by using your by using what? By using your block diagram, library in that Xilinx worksheet. We are having an inverter here. So where is the inverter? Just a minute. Yeah, this is an inverter. You can take the inverter, then you can use another type of application. For example, I'm taking that inverter and I'm showing some small example and I want to implement in FPGA. Right. So for that, I require that input control C and control V. Same things I'm using here also. And I want to use the same input signal. Yes. Output. Right. I want to use the same data. I want to use the same data here. So I want to see how many what you call that images right now. I want to view 3 images. One is input image, another is 2 output images. So output images. I want to change this property also. It is only inverter, but I am not taking any delay. It is 0. Click apply and OK. Now again I want to save this design and rerun the design. You can see this is our first image. When you are added your how much of value you are added? 50. Okay, you added a constant value of 50 to original image. That's why the image is coming like this. But what I'm doing in the next viewer, I'm added an inverter to view my actual image to inversion. This is my inverter. This is my inverter. Okay, fine. So like that, you want to change your algorithm. You want to change your algorithm manually, or you can take XOR gate, or you can take RGB. For example, I'm having a color change and gray code conversion, like what you call? So y is equal to 0.3 into 0.3 into R. First, you can into R. You can take this is an R. Plus you can added in terms of 0.57 into RG plus you can take 0.11 GB. This is one type of equation for the gray code conversion. So for this equation, what you want to do, how to take the value, or you can identify that 0.3 is multiplied with R. So you can take, we are having how many inputs here? The input side is RGB. R is multiplied with 0.3. Okay, 0.3. That is by using, you can remember this equation. By using CMUL, here we are having the multiplication, in the additional block we are having a CMUL. If multiplication, you want to multiplication, 0.3 into, plus, what is another value? 0.57 plus 0.11. You want to add the three values. So, for the adding of three values, you want to take CML as well as adder. CML as well as these two block sets or toolboxes has been sufficient for the gray code conversion. You can easily generate it. So, fine, very good. So, coming to that, I am doing right now directly a FPGA implementation. So, I am connecting my FPGA board to my my system. Just a second. I am connecting my breadboard. What I shown the breadboard is looks like this. In the previous slides, yes, this is the breadboard I am connecting. I am connecting the power cable and I am connecting the data cable to my system. Okay, power cable to the platform and data cable to my system. Right. So then I want to turn on my system. Board. I want to turn on my board. Then the connection. JTAG is a programmable port, and we are having another type of port. The same port is UART. For the UART communication, you are using this UART port, and JTAG for the programming purpose. You can customize, okay? And very good. And right now I am connecting on my board. Okay, I sound on my board, so you can view the sound also. Right. So I was closing this. This output information. Now I want to view so I am reviewing that inverter also, this inverter. Okay, I want to remove this. Just deleting. Yes. Now I am using the board. How I am using the board you can see. Going to the system generator icon, double click on that. Going to the system generator icon, double click on that. Meanwhile, I am saving once again because I removed the design now. So, fine, very good. I save that design and double click this system generator. So now I am choosing the board. I am choosing a board. The board is in terms of Z board. Okay, I am choosing the Z board. It is an evaluation board. So I choose a board and it is a type of compilation type I am taking as an hardware core simulator JTAG. Hardware core simulator JTAG because I want to get the output in here itself only. So this is an selected JTAG. If you want to take VHDL or Verilog, you can take your own language. What you are familiar with, you can take that language, no issues. But it is not that much of change has happened here. Then now I am clicking apply. I take the JTAG and I select on my board and I am clicking generate, apply and generate. So for the generation, it is going to start your what do you call the system generator performance. So it will take a while. Hardly it will take around 5 minutes, I think so. Okay. Because it's a very small design. If you are going for the bigger designs, it will take around half an hour also. So this system generator gives you that toolbox is only for yes, this part, the algorithm part only we are most of, because the system generator is only where we are using the system generator it is related to your Xilinx toolbox. Xilinx toolbox. That is the most important point we want to make sure that. Question is CNC. CNC means exact abbreviation, sir. Yes, sir.
Mr. Pradeep,
Sir.
by the time this compilation gets on, we can take up the questions. That will save our time.
Okay, sir.
So, dear participants, if you have any questions, please put it in chat box so that we can take up those questions.
Okay, sir. So this is another type of same design I'm taking here, but here I'm taking one example as RGB. What I mentioned it's opening. What I mentioned the equation is 0.3 and 0.57 and 0. How I design this, you can view this output here. See, this is 0.3, 0.59 and 0.11 and I'm adding here. And for this addition, I use it to perform some different operations. Direct gray code, this is, I'm adding some here threshold. This is a threshold purpose. I'm using this block, the same block, and I'm adding some noise here, addition with respect to certain constant. And again, I'm also adding something constant. So I want to wrap this one to view your output, how it looks like. The same module, I'm using the pre-processing and post-processing block. Meanwhile, we can see the chat box. In the chat box, sir, one of the question is CNN. What is the CNN meaning full form, sir? That I know.
No, but that is not to me. Wait a minute. Let me host.
Neural networks. It's from neural networks.
Convolutional neural network.
Sir?
Convolutional neural network.
Yes, sir. It is also possible. What you want to do in the convolution neural network with the blocks or what are the designs you are having, you want to identify the blocks near the Xilinx blocks. You want to identify the Xilinx blocks, then only you can enhance your design in the neural network inside with respect to an FPGA. Yes, it's certain way it's possible. Any other questions? And compilation is going on.
Mr. Pradeep,
Are appearing right now. Sir,
the questions are directly put to you as a presenter. They are not visible to me. If there are any, please keep on watch and we can answer at that time only, at that part time only. In the compilation. Okay.
Right, sir.
As soon as compilation finishes and we are on this, we can keep the things off the shelf and then we can again come back.
Definitely.
Yeah.
Right. You can view this is a RGB what I mentioned previously. According to that, I designed this one, the block, and I'm for giving so many things. So this is my main code. Main image. This is because I'm given my input and taking the input image from the register. R is red color. That's why only some sort of image only it will view. That's why it's pattern right. Later on, I'm making some gray there. This is gray actually, I think so. And this is the addition value, and this is an inversion value, threshold values. These are the threshold values existing here. These are the part we are mentioning here for the same design. These are the designs we are mentioning here. This is a system for threshold. So threshold it is given for 2. I think so. It is 2 is the threshold. Yes, 2 is threshold. This is the threshold. And want to see what is the threshold. View 3. The 3 means threshold. Where is 3? This 3. This is 4. This is the threshold value. Okay. This is the threshold value for that design. You can easily identify it. And the processing block is company. So yes, any more questions, sir, from the participant side? Meanwhile, we can discuss the things because still the compilation is going on. this is the last step. I'm waiting for that block to generate. After the generation, we want to directly jump into the FPGA and view the output. Okay, that is the part is pending to our friend. So the processing is paid. From the platform side, any more queries? Should that our contact number is 90009000485. And our mail ID upload 2000 So So we can do our own designs based on these factors, and we can easily enhance the design.
Mr. Pradeep, there is one question.
So if you are yes, sir. Yes, sir. For where we get the what is XY link in Finlink. So what is XY? XY link means
Probably Ruchika, your tool. Okay, she's saying, Madam Ruchika is saying that your tool, expiling tool.
fine. You are asking for Xilinx, I think so, ma'am. Yes. Okay, ma'am. Well, Xilinx, it is available for the in Xilinx website actually, but it is a paid version. It is not a freeware. It is a paid version. Then after that, you want what type of version you are selecting for Xilinx Vivado? The same version. The compatible version of MATLAB you want to install. Compatible version. Compatible version of MATLAB you want to install. So what I did is, I am using the Vivado 2019. You can see on my desktop. I installed the Vivado, Xilinx Vivado as 2003 version 2017 again. For the MATLAB application point of view and image processing point of view, I installed 2019 also. Xilinx 2019 and the compatible version of MATLAB also 2019. In MATLAB you can see in M. Okay, I'm typing here. You can view that one. So this is the MATLAB I already installed. The MATLAB I'm installed as 2019. Okay, so some other versions is available for some experiment. None of the free versions are not available. These are the industrial standard versions. Both are even MATLAB as well as some part of MATLAB you can search for some freeware, something like that. But for the Xilinx it is not possible, madam. Right, thank you, ma'am. So, any more questions from the participant side? Oh, it is almost completing. This completion also must be come to the end. I think so. It is around 60 to 70% it is completed. Still 30 more.
Sir, there is one question in question answer section.
Sir, nobody is asking, sir. I'm waiting for the
Yes, yes. There are questions. Mr. Pradeep.
Sir, what is the another question, sir?
Yeah, I will read it for you.
Okay.
Can standalone system be made using FPGA platform and MATLAB simulating program built in?
Standalone system can be made using FPGA platform and MATLAB. But actually, yes.
Probably not.
What is the meaning of standalone? In your point of view, let me know, sir. Then I will give the answer to you. Because MATLAB and FPGA is one of the latest tools. These two are supporting for so many designs.
Yeah,
Part of image processing and video processing signal tablet.
Mr. Pradeep, just we will get it clarified from the person who has asked this question, participant who has asked this question. Professor Amol, can you just clarify what do you mean by standalone system? I mean, what is your
opinion?
What you want to ask actually?
I think Amul sir, are you there right now? You can shoot the question again for the clarity of what is standalone in your point of direction.
I think Professor Amol is not there right now. Then we can go ahead with other things.
Yes, other thing is yes, he is.
Yeah. Is that over? I mean, simulation is done. Compilation, what I mean to say.
No, that's still is running, sir. I want to see the output. Yes, yes, sir. Looking for that one first.
Yeah.
Yeah. Just a second, sir.
Yeah. How much time it usually takes?
We take a lot of time.
Yeah, Mr. Pradeep. Professor Amol has clarified, he wants to say that he means standalone means system with hardware, system as a product with hardware in the form of FPGA and software in the form of MATLAB. Okay. Okay.
Yes, sir. That thing only we are doing. The FPGA in terms of hardware and software in terms of MATLAB. But what I'm mentioning is, if you want to use the FPGA as a hardware in the MATLAB point of view, you want to make a compatible version, configure that MATLAB and write it at a time. Then only you can use the MATLAB FPGA as a standalone.
Yeah. Well, Professor Amol, I hope
You got the answer, sir.
you got the answer for the question. Mr. Pradeep has answered.
Okay, sir. So any more questions, sir? Yes, somebody is asking some questions. Since MATLAB is not a freeware, can we perform the same demo show in any other open source? Yes. So if you're having any open source like Scilab is available, but the Scilab doesn't support the FPGA configuration. So you cannot able in that software. If you are thinking MATLAB related to open source software, maybe a Scilab as per my knowledge is there. But there is not one.
MATLAB freeware है ना अभी? MATLAB freeware वैसे earlier version तो freeware ही है ना?
No, MATLAB is not a freeware, sir. Actually, it is also purchased version, but some part it is available in open source. It's a cracked version.
Yeah, always license version is always preferred.
So yes, okay, sir. Thank you. I will answer again the questions coming to that. Right now, we can just generate it.
Yeah,
So
MATLAB
this is the JTAG console. So I'm taking the JTAG console to my main design. Okay. In that main design, is my screen is visible? Sir?
Yes, yes.
Is my screen is visible?
Yes, sir. Yes, sir.
Right. Thank you, sir. So I'm connecting this input and output for the direction because this is my system generator. So I generated in comparison so the data. So when my hardware is only connected to my system, then only this data will be generated. Still my hardware is an on session. Having camera. Camera, where is the camera? So camera where it is available? Right.
On your phone, beside your name, it was some camera symbol. Sir, beside
Sir?
in sequence, beside your name, it will show camera symbol.
Besides the name, sir.
Apartment.
Yes, yes. Yeah. Is a view? Okay, very good. So this is my hardware. So for this hardware, I connected the cables into the JTAG as well as power cable. Now I'm starting with run simulation. For the same thing, I want to get two outputs in the same manner. What is the system is giving the same manner? For example, I want to close this one. Yeah. So this is my input. Actually, system MATLAB output. This is the first one is MATLAB output. The second one is FPG output. The second one is the FPG output. So I'm running right now. Run simulation. It will take 1 or 2 minutes. That's it. Because already it is generated. So when it is going on to implement, there is a it will be below. Yes, the output is coming. I think so. View online. Go to. So here the blue lady and blending that yes, very good, very good. So we can observe that when it is dumped into the FPGA, so the only view one means sorry, the viewer is this is your MATLAB output. This is your MATLAB output in previous what we see. After generating of your hardware, when you are connecting and debugging into the hardware, when the hardware is debugged, when the general LED has been blinking, I think everybody is gently put in this is view. So you can observe both the same images has been displayed. So like this, you can view the output and basically, what do you call that? Here, so okay, you can show the details how much. See, so the compilation time takes how much seconds. Like this, it was also mentioned. Okay, you can take this one, and in the same factor, there is a thing called here automatically targeted different metrics has been also generated. So what is the actual location of our file? In design, yes. In design, what is this is my location of my file. This is netlist. This is my netlist. If you want to open this netlist, in that netlist, you can see that the hardware core simulator. Hardware core simulator, there is a this is your Roboto project file. Roboto project file. So in that Roboto project file, you can easily identify that. If you want to open this icon, Roboto icon, and you can go to internal design, then you can easily identify the power constraints, easily identify the area constraints, easily identify the total delay constraints also. Okay? For your design. Here it looks like an hardware core simulation file, and it is in terms of here the source, in terms of the file, I think so. Something like that. This is the .v file. Design 3 module. The design 3, when I'm starting my project here, this is the design 3. That is in terms of module V file. This is an hardware core. it is generated by a system generator. So by using a variable constant, these are the things you can easily identify. Okay. Right. So you can see that next also generated. So these are the inputs and outputs of your image processing application by using hardware of FPGA. So right. Any queries, sir? Anybody have any queries still? I want to know. Yes. Somebody is asking that MATLAB is not a freeware. Thank you. MATLAB is not a freeware. Okay. MATLAB is not a freeware. Anybody have any doubts still? Or anybody have any queries, sir?
I suppose no. Because in between we have taken up the
yes, sir. Okay. In between also, okay. Right now, also in the ending of the session, participants, do you have any queries? Let me know. I want to clarify as soon as possible.
I can do it. It's a recording somewhere, no?
Right.
Yeah. Mr. Pradeep, I suppose there are no queries. That's it.
Yes, sir. Thank you very much, sir.
Yeah.
Yes.
Have
So,
you finished from your end?
One thing to the sir?
Have you finished from your end?
Yes, sir. I debugged into the FPGA. So my end is completed because we are concentrating on FPGA point of view and hardware implementation. Yes, my end is also completed. And can I wind up? Is it okay?
Yes. Please.
Yes. Thank you for giving this opportunity, sir, from your college side. It is very helpful to you. I think so. So not only as a participant, I'm mentioning that use both the tools like MATLAB as well as Xilinx and take awareness and generate as many as possible designs to enhance that. How to debug into the FPGA is also very important because I'm mostly concentrating on VLSI sector. I was not good in the image processing applications or video processing applications. But as a part of one of my core is ECE, but I also want to think these types of design. So I'm looking into these types of analysis and enhancements of design by using these hardware, and I want to doing a lecture and helping for you people. So I think so. This session is very useful to you at point of my side. Thank you very much. Still, anybody have any queries? Let me know. Or if you want to ask any doubt or anything, you can call me as 90009000485 as a WhatsApp number, and you can mail me applyworld2017@gmail.com or applyworld2018@gmail.com. These both the things we are answering to you. Okay. For tool support or hardware support also, you can contact us. Thank you very much, sir. Thank you.
Yeah. Thank you, Mr. Pradeep.
Yes.
Yeah.
Sir.
Yeah. So, we have come to the end of day 4. Session 3 has ended. I am thankful to the experts from Apply Volt Hyderabad, Mr. Pradeep and Mr. Ramesh, who had taken pains to prepare this and provide hands-on session, a very interactive session to all of us in the like as far as image and video processing and its converting to FPGA is concerned. Thank you, Mr. Pradeep, once again, and we will be keep in touch with you. And I hope again this the content provided by and inputs provided by Mr. Pradeep to his demo will be helpful to all the participants in taking away their research and also as a teaching content to their students at their respective institutes. Well, dear participants, we have come to the end of day 4. It was little bit delaying in the time, but I hope you understand how it went, and I hope all of you will be with us as far as this type of little rescheduling or maybe a kind of thing that has taken place and that has extended this to this time. I request that we are closing this. Stay home, and then that's all from my side, our side, as far as day 4 is concerned. Do join tomorrow, day 5, last day of our 1 week online FDP at 9:55 sharp, so that we will begin with session 1 of day 5 tomorrow. Thank you very much. Bye bye.